What is up, guys? I just recorded the tutorial for the no flex zone ability, which you guys have been requesting. I just want to let you know that it is fucking terrible because I just woke up. I'm extremely tired. It's really it's really bad, but it shows you how to write the code, so I guess that's good enough. Yeah, so I hope you enjoy. What is up, guys? Steezy here with another tutorial. In this video I'm going to be showing you how to make the no flex zone particle effect, which is what I called it, just because I thought it was really stupid, but it's basically creates a sphere around you. There's a lot of different variations of it you can make. This is in one of my other videos. Ignore that. Yeah, so this is the no flex zone ability. It just makes a sphere around you. I just woke up, so I'm pretty tired. Hopefully this tutorial isn't too sloppy. But yeah, so let's get into the code here. So here I have the basic stuff. We have our toggle sneak event is what's going to trigger this no flex zone particle effect. We get our player who does the event. We get the location of the player. And then here we start our Bukkit Runnable, which is going to loop through a bunch of times with different values, which will create different locations at which the particle effect is displayed. So in our Runnable here, we're going to have a variable phi, which is basically it's the angle from one of the axes. I don't remember which one. Yeah, it's the angle from like the positive z-axis and three-dimensional coordinates. So we're going to be using phi, theta, and r, or rho, which is the radius, and theta is another angle from the positive x-axis, I believe. So to do this, we want to start off by incrementing our value of, or once we start looping through the body, we want to increment the value of. Man, this tutorial is going so bad already. I'll try to get through it though. I've been really busy lately, and I don't really have a lot of time today, so I want to just get through with this quickly. So we have phi. It's going to be phi plus, let's do math dot pi over 10. Now we're going to have so if you don't know how a runnable works, basically it'll execute this body here once per tick, because I have a 1 there, and it'll keep looping through until here I have a condition. If phi is greater than pi, it's going to cancel the loop. So it's going to keep running through, and basically each time it runs through, it creates like a full circle. So it runs through, like, if you count them, there's like 10 circles or something. Yeah, because it's divided by 10. That makes sense. So this main part creates, each time it runs through, it creates a circle, and to create the circles, we're going to have a bunch of particle effects that are spawned instantaneously, or like at the same time, to create those different levels of circles. So here we're going to be using a for loop to do that. So for theta now, which is our second angle we're using, it's going to start at 0, and it's less than or equal to 2 times math dot pi. And we're going to increment the value by, let's do math dot pi over 40. So this will create like 80 particles per circle, I think. Yeah. So in the for loop now, so in this body of the for loop, this is going to be what's creating the individual circles. and each time it executes this for loop, the value of phi is going to be constant for each time it executes. You know what I'm trying to say, hopefully, because I'm retarded. So it changes the value of phi, it gets to the for loop, runs through a bunch of times, creating individual particles which create a circle, and then it will go through again to create the next circle with a new value of phi. If the value of phi didn't change, you just keep creating circles in the same location. So that's why we're changing the value of phi here. So here we're going to have, now we're going to be defining the coordinates at which we're going to spawn the particle. So we're going to do one more thing I forgot. We need the radius of the sphere that we want to use, so we're going to have double, let's do 1.5. There we go. So now we can define the coordinates. So we're going to do r times cosine of theta times sine of phi. Y is going to be r times cosine of theta, cosine of phi, and we're just going to add 1.5 so that the sphere is kind of centered around the player's head rather than the player's legs or feet. And z is going to be r times cosine of theta That's wrong. I meant to be sine. R times sine theta times sine of phi. So these are the Cartesian coordinates for a sphere. I'm not going to go into detail on how you get this, maybe in another video if you're really interested, or you could just Google like how to get from like spherical coordinates to Cartesian coordinates, or how do you derive the Cartesian coordinates of a sphere, whatever. It's just like our cos theta times our sine theta. Well, they'd probably refer to this as rho. It's just the radius. And then theta and phi are the angles from the like positive x and positive z axes. Yeah, so I'm not going to go into detail on that, but you can look it up yourself if you want to know. So after we define our coordinates here, we're going to add x, y, and z to our location of the player. And then display the particle effect at this new location. Let's do drip water, that's what I was using before. Dot display the location, comma 0, comma 0, comma 0, comma 0, comma 1. And then after we display it, we want to kind of reset it to get back to the original location. So we're going to do location dot subtract. And then, oh shit, I already had that. That doesn't go in there anyway, I don't know what I was thinking. Oh wait, yeah it does. Never mind. So this is gone, we have that there. We don't need this. And then here we have a check if phi becomes greater than math.pi, we're going to cancel the loop. So let's test it out, make sure it works fine. And there we go, it works, just like before. Yeah, so that's how you make it. What else? Fuck off, cow. So some modifications you can make to this. Let me just change this to flame, just so it's easier to see. If you wanted to, like in my no flex zone video, I had it kind of oscillating up and down, and if you want to do that, you can. Fuck, how do you how do you do that? You have to make this greater than 2 pi. So what it does. Wait, no, that's for the circle. Here you want to make it greater than. Here. So if you make this 2, let's do 4. No, let's do 2. So what this will do, before, when it starts at the top, it creates circles all the way down to the bottom and then stops. And that's because phi became greater since we're increasing it here. Phi becomes greater than, when it becomes greater than pi, it just cancels. So if you, ignore that. That's way too many particles, but you can see it goes down and then back up again, down and back up. And if you make this larger, like 4 or 8, it'll keep going up and down. To make it look nice here, we could decrease the number of particles in the circle, in each circle, because right now it's kind of dense. Yeah, so it goes back and forth, up and down. And that's how you do that. One more thing. What else can we change here if we want to make it different? You can change the radius. Let's make it 5. If you have a larger radius, you're going to want to be using more particles, so it's not really open. There'd be a lot of holes and shit. If you want to make the like, you could change the X and the Y or whatever if you want to make it go in the other direction. There's a lot of stuff you can do if you just play around with it. Let's just check this one out real quick. Yeah, so there's not enough particles being displayed, and that's probably way too big. But you know, it's still kind of neat. Yeah, so I think that's about it. I'm kind of just going. But yeah, so I'll explain this ray gun thing. This guy wanted me to code some stuff, some particle effects for a server. It's called grandcraftauto.com, the world's best GTA Minecraft server. So I don't really know when that's coming out, but I think soon. Also, Dojo's coming out soon, maybe. We'll see about that. Yeah, so get excited for that. Yeah, I'll see you next time.